which of the following conditions implies that xn tends to 0 in distribution as n tends to infinity? So basically it is given that xn converges to a point mass at 0. So that means like probability of this xn is equals to 0 is tending to 1. So and like xn is following binomial n comma pn. So probability of xn is equals to 0 is nothing but 1 minus pn whole to the power of n. So the standard approximation gives that 1 minus p whole to the power of n is approximately e to the power minus n pn, and pn is small. So more usefully, a sufficient and convenient condition is n into pn tends to 0 implies 1 minus pn whole to the power of n tends to 1. So xn tends to 0 in distribution. Now if we examine like each and every option, so first option says like limit n tends to infinity, pn is equals to 0. Now this is not sufficient because, for example, if I take pn is equals to 1 by n, this pn tends to 0, but n into pn is 1. So probability of xn is equals to 0 is nothing but 1 minus 1 by n whole to the power of n, and this tends to e to the power of minus 1 as n tends to infinity. So this is not equals to 1 clearly. So first option is clearly wrong. If we consider the second option, limit n tends to infinity, we're having like limit n tends to infinity, pn is, probability of xn is equals to k is 0 for each fixed k belongs to 1. Now this cannot imply convergence and convergence to degenerate 0, because in particular it says like probability of xn is equals to 0 tends to 0. So which is opposite of what we need. We need like it should tend to 1. So second statement is also